Question 7. ABCD is a rectangular shaped steel gates, okay? AB is parallel to PQ. PQ is parallel to RS, parallel to DC. So basically all these are parallel lines, basically what we learned earlier, okay? It goes, calculate AP. Well, AP is the same length as BQ. B to Q is 1/3 of 1.8. So divide 1.8 by 3, and what we get here is 0.6. So each one of these is 0.6 long. And because these are two parallel lines, and we know that AD is parallel to BC, because two rows are parallel, that means that it's also AP is 0.6. Okay? Now guys, so the first answer is it's 0.6. Now, calculate XY. Now, to calculate XY, Keynes, to calculate XY, what you're going to do here is you have a triangle, okay? And the triangle is 2.4 wide and 1.8 down. So 2.4 across, 1.8 down. And what we're going to do is we're going to use Pythagoras' theorem, and we're going to find out what the length is of A to C. We'll call it X, okay? So X squared equals 2.4 squared plus 1.8 squared. Did anybody know what 2.4 squared is?
5.76.
5.76. Is that both of them added together or just one of them on its own? Okay, that's grand.
And then the other one was 3.24.
Thank you very much.
And 9.
Cool. Yeah, I reckon you're dead right with that. 9, yeah. Now guys, it's 9. X therefore is equal to the square root of 9, which is 3. Now guys, see A to X. A to X, the line AC is broken up to 3 equal parts. This means A to X to Y has to be worth 1, because it's a third of 3. Now finally, RAXZ is a parallelogram. Okay, so let's find this parallelogram here. Just delete the, no, don't delete that. Okay guys, so we're going to find out where this parallelogram is located. Okay, so it says R to A is here. And then it wants me to go from A to X, which is here. And then it wants me to go from X to Z. Now where is Z, lads?
It'll be directly down.
Oh, it has to be down here, doesn't it?
Yeah.
And then that's our parallelogram. So we know that Z is here. It's the only way I can make a parallelogram out of it, because it's the ordering of the letters, okay? R joins to A joins to X, and we know that it has to be the same length as AR and in the same direction, so that means that goes directly down, and then we know that RZ has to be the same as AX, so that's process of elimination, okay? Okay, we did that.
They're not have to give you it.
No. Okay, guys, calculate the area of the parallelogram. Well, we know that this is 1, okay? What we also know is that 2 of these is 1.2. Because it's 0.6 a gap. Remember we did it earlier? No, that's 0.6, that's 0.6, and that's 0.6. The 3 of them combined is 1.8. So 2 of them is 1.2. The one we got earlier is a third. It's AX, okay? Now guys, we're still we got the 1.2. Does anybody know what PX is? P to X. I reckon P to X, because these are the same length, I reckon it's going to be a third of 2.4. Now I'm going to tell you why. Think about it this way, guys. When you travel A to X, X to Y, Y to C, they go across 0.8 every time and down 0.6.
It is
because the diagonal is 1.
Yeah.
So what we can do now is we can say that the perpendicular height is 0.8, because it goes across 3 times. See the way there's 3 of them? A to X, X to Y, Y to C. It has to go across 0.8 every time to make it from one side to the other. So now we know that the perpendicular height of the parallelogram is 0.8, and the base is 1.2. So area equals base multiplied by height, which is going to get us 1.2 multiplied by 0.8. Anybody know that? I think it's 0.96 meters squared. So we check that out.
Yes.
Thanks. Okay.